So the given problem is Pacific Atlantic water flow. So here we are given a matrix of m into n size. So each index represents the level amount of water it contains. So we need to find all those indexes such that the level of water which could flow into Pacific Ocean and Atlantic Ocean. For example, if you take this index as as the water can flow in four directions, which is up, left, right, and down. So if the neighbor element has less level of water than it, then it can flow through. So for example 5, if you check, if you traverse through the left side of that index, it is 4. As 4 is less than 5, it can flow through. So again we will be again uh, going through the DFS for this 4, and for this 4 it will again check in the 4 directions: up, left, right, and bottom. So if we go to left side, we can go left, right, because 4 is greater than 2. So it can flow through this 2. So as 2 is completely beside the Pacific Ocean, the water from 5 content goes into Pacific Ocean. Similarly, if we traverse towards the right side, so as 5 is greater than 3 and 3 is greater than 1, all the water content from this 5 block can go to Atlantic Ocean. So the 5 could be one of the index which can flow through Pacific Ocean and Atlantic Ocean. So in this way we need to find all the indexes which are applicable from the entire matrix. So if we add graph travels technique for each index, it would take a lot of time complex. It would take order of m into n whole square, but that is not optimal. So the optimal way could be, if you see clearly, all the elements which are in the edge can flow into the adjacent ocean of it. Similarly, for four directions, it is the same. Four edges is the same. So the best approach would be, we will be just taking the first row, and we'll be checking if for every element in the first row we will be checking through DFS, and we will check if the next element, this one, can flow, can the Pacific Ocean enter from here to here or not. So if it is 1 and if it is 3, such that the previous height should be less than the current height, then only it can flow. So similarly we will add a graph travels technique for this row and this row, the last row, and this row and this row. So let me code it. So I will just declare the rows as len of height, and the number of columns would be len of heights of 0. So I'll be just adding, I'll be declaring two sets, which is Pacific. I'll just make a set for this, and I'll write ATL as a set for Atlantic Ocean. So each set contains the indexes set for each ocean which can flow. So now I'll be just creating a signature for graph traverser. So I'll just put a visit, and I'll just give here as a previous height. So it will just compare with the previous height and check if it will be flowing or not. So for every condition we'll be checking that if R comma C is already in visit, what we'll be doing, we'll be just returning, because we don't want it, because it is already in visit. So what are the cases in which we will be just returning? even if through graph traversal, if we approach somewhere, if r is greater than less than 0 or c is less than 0, and what might be the cases, even if r is equal to rows or call c is equal to columns, and the main condition, which is if pre height is greater than the current height, which is heights of r comma c, will be just returning. So if all these cases are not true, what we'll doing, we'll be just adding the item into the visit. Similarly, we'll be just traversing to the 4 directions, right, which is r plus 1 comma c comma visit and preview height. Similarly, we'll be doing for 4 directions. You can also do this with loop, but I am just calling with these r minus 1 c minus 1 c plus 1. So this would be our DFS method, and we will be doing for rows and columns, right? So for example, we will be taking all these columns and we will be checking if they go into specification or not. So for that, we need to just write a loop for I in range of, these are the columns, right? Columns, yeah. In columns, what we'll be doing, we will be just calling DFS function for this. So as it is row, it will be changing the columns, right? So 0 comma I comma, I will just adding visit, I will just put it as specific because it's specific. I will be just giving the previous height as height of 0 and I. Similarly, for the last row, if we will be checking if it is good, if these are coming into Atlantic Ocean or not. So it will be like DFS of rows minus 1, this will be I, and this will be rows minus 1, and this will be I. Similarly, we'll be checking for these, right, these rows, these rows, like this, in this way. We'll be checking in this way for Pacific Ocean and in these ways for Atlantic Ocean. We'll be just calling the method. For this, it will be like 0 comma it will be I comma 0 comma Pacific Ocean heights of I comma 0. Similarly, DFS function for this row in this direction, it will be like DFS of, it will be calls I comma calls minus 1. We'll be checking if it is in Atlantic Ocean, right? So it is ATL comma heights of I comma calls minus 1. So in this way, entire matrix will be made of. So we'll be just making a return, we'll just storing it in a result. We'll be adding for I in range of rows, for j in range of columns if I comma j in PAC and if I comma j in ATL ATL right? Yeah, ATL. We'll be just adding this to the result. We'll just adding in the form of arrays because the given output is in form of arrays. Yeah, now we'll be just returning the solution which is result. So okay, syntax error in line 8. Sorry, it's not using, it's just in. Okay, line number 16. It's spelling mistake. Oh, many spelling mistakes, sorry. So just I have just given here as capital H, sorry. I need to give the same for all this. Oh, my final result is stress. Okay, it's giving me wrong answer. Let me debug. Okay, we need to just give this for height, right? The current height will be the previous one for that. Okay, what more cases? Okay, sorry, I just this one. This will be ATL. Yeah, now it's accepted. Just put it as your ATL instead of PSC. So in this way, which will be solving the problem using graphs. Thanks.